So I want to solve the differential equation y prime. So the second derivative of y plus 4 times y is equal to sine of t. And we have the initial conditions, y of 0 is equal to 1 and y prime of 0 is equal to 0. So again, I take the Laplace transform of each side and get s squared capital Y minus s times y of 0 minus y prime of 0 plus 4 times capital Y of s is equal to 1 over s squared plus 1. So I solve for capital Y, so get capital Y times s squared plus 1 is equal to 1 over s squared plus 1, and so capital Y is equal to 1 over s squared plus 1 times s squared plus 4 plus s over s squared plus 4. Sorry, I forgot this 1 over s squared plus s. That was this s here that we took on the other side. Okay, y of 0 is 1. And so if we took it on the other side, we have minus s here, so we have plus s here. Sorry, so it's this s over s squared plus 4. And so now we do partial fraction decomposition. We write a times s plus b over s squared plus 1 plus c times s plus d. This is a d here, d over s squared plus 4. And so we can solve for the coefficients using partial fraction decomposition. We won't do that here, but if you solve it, you will get the following. So capital Y is equal to a third of 1 over s squared plus 1 minus a third of 1 over s squared plus 4 plus s over s squared plus 4. And so if you take the inverse Laplace transform, the inverse Laplace transform of 1 over s squared plus 1 is sine of t, and you have the 1 over 3 in front. And here we can multiply by 2 in the top and bottom. And so here we have a 2 here. This 2 goes with this 1 over 3, so we have 1 over 6. Okay. And this 2 here in the denominator, so above the fraction bar. We have a 4 here, so 4 we can write it as 2 squared. And so this is simply the inverse Laplace transform of that is simply sine of 2t. Okay. And here, the inverse Laplace transform of s over s squared plus 4 is simply cosine of 2t. Yes, so yes.